Hi everyone. This week we're going to be talking about programming for security professionals. This correlates to Chapter 7 in your textbook. So what's this about? Essentially, all the tools that you use, whether it be built-in operating system tools or tools that you've downloaded or tools that come with Kali, these are written either as scripts or as applications. And as a security professional, as a cybersecurity engineer, it's really good if you can understand underlying programming concepts so you can build your own tools, build your own scripts, and automate a lot of the processes that you do every day. Why bother doing the same task over and over and over again 1,000 times when you can have the computer do it for you? Now, this doesn't replace intuition. This doesn't replace you as a job. It's not a robot replacing you as a job, but essentially you should automate the boring stuff. There's a Python book out there that I use in one of my other classes on Python scripting for cybersecurity, and I'll send you those video links in Blackboard. But you should really get an idea of why programming is good, programming concepts, scripting, building applications are good for automating your tasks and helping out with some of the more, not only mundane portions of the job, but extremely complicated portions of the job. So the chapter in this book talks about C, talks about Perl programming, web pages in HTML. So for instance, maybe you want to build a phishing page that simulates how a real web page would look to get end users to log in, to harvest passwords and credentials. Maybe you want to write a script that goes over log files and looks for key IP addresses or usernames that would be helpful in your analysis. And then finally, the chapter talks about OOP, or object-oriented programming. So it begins with functional programming, writing blocks of code that cover repetitive tasks, and it ends with talking about the concept of classes and objects, why structures in programming can simulate properties, so getters and setters, essentially verbs or actions in methods. You can use this as a concept in real life that an object can do something or have properties or attributes, and that's what a class offers in programming. So, getting into it, computer programmers have to follow rules. So there's syntax, there's language. Essentially, writing a program is all about conveying logic to a computer. That logic can be conditional statements, that logic can be expressions where it's variables and operators. There's a lot of syntax involved, and it says here, one minor mistake and the program will not run. It depends on the language. Right here, or worse, it will produce unpredictable results. You could have what are called race conditions in the code, where you're expecting certain processes to run either in series or parallel, and one process finishes before another, one process interacts with another and does something unexpectedly. But being a good programmer takes time and practice. I've been doing this for 20 years in terms of programming, and I still make lots of mistakes. But I will say I made more mistakes in the beginning. And I still make mistakes today when I learn new languages. So yes, it does take time, and you have to keep up with all of the changes. So, you can begin writing program with little knowledge of programming fundamentals, absolutely, and I really encourage you, they talk about C and Perl in this. Start with a programming language like Python's, or a scripting language like Python. Start with PHP. These, and especially Python, is so much similar to pseudocode, so essentially writing code and logic in English. And then translating that out. Python, instead of using braces, for instance, uses indentation to delineate its code block. So, yes, you can begin writing programs as long as you have a basic concept of logic. Do you understand, if you have two items, A and B, what does the word and mean? What does the word or mean? Do you understand loops? So, essentially, can you envision in your mind iterating over and over and over again to perform a task, looking at a counter, the concept of lists? These things, once you get the hang of them, a lot of times that doesn't take syntax, that just takes understanding them in your mind. fun. So apparently the book talks about bacon, lettuce, tomato, branching, looping, testing. I think they just wanted to come up with an acronym. There's lots more concepts in programming than branching, looping, and testing. But we'll go with what the book says because that's what your quiz is on. So a function, what is a function? Also called a method within a class, which may or may not be talked about later, but it is a block of code, and that code carries out a single task. That task might be repetitive, and that's the point of a function. It's to take a block of code that might be repeated over and over, and instead of typing it over and over again, you can simply reference it. Branching, this is the concept of going from one area of a piece of code to another. Conditional statements. Do you go this way or go that way? Well, if this is true, do this. If this is false, do this. You can have if statements. You can have switch statements. Really dig in. If you don't have a background in programming, you need to dig into it. But branching essentially allows you to execute different parts of your application. Looping, as I talked about, is iteration. It's doing a task over and over and over again. Sometimes you have a counter. Sometimes maybe you have a list of objects and you iterate over each item. That's looping. And then testing, it's conditional statements. This wants to call it testing, whatever. If this, then that. If A is true, do this. If B is true, do this. That is the concept of conditionals. Here is an example of a program. So, for instance, you have main, which is an entry point to an application. You have an integer. So an integer is a number, 2 to the 32nd. A equals 1. Okay, so we're naming a variable A. We're setting it equal to 1. Now we're having an if statement. If A is greater than 2, then print A is greater than 2 to the screen. Well, we know A is equal to 1. So we don't do this, else get out. So we're going to branch out because A is equal to 1. A is not greater than 2, so you jump to get out. And then get out is a block of code that now iterates over the variable A from 1 to 10. And each time it loops, you add a number, and then you print I'm in the get out function. So that prints out 10 times. Once you get good at programming, and I rattled this off, right? You're able to read this like a book. You're able to read this like a language. And all it takes is understanding the underlying structures of a programming language. And it doesn't matter what language it's in, whether it be Perl, C, C++, assembly, PHP, Python. Doesn't matter. The concepts are all the same. And that's why it's good in programming to really understand the underlying concepts, because then you can read and understand anything that's given to you. Branching, looping, and testing. So what is an algorithm? An algorithm are the steps involved in doing something. Making a sandwich. Okay. Get out the bread. Take the twist tie off the bread. Unravel the plastic. Take 2 slices of bread out. Take a plate out. Set it on the counter. Set 2 slices of bread on the counter. If the bread is rye and the meat is whatever, turkey, use mustard. Place mustard on bread. Else, if the bread is white and the meat is bologna, place mayonnaise on the bread. That's an algorithm. It's a series of steps. Now, obviously that is a very parochial view of an algorithm. Algorithms can be very complex, can be very eloquent, but essentially it's a series of steps to perform a task. A bug, it's an error in your code, causes a problem. You hear bug, that's all it is. And then pseudocode, as I mentioned before, that is when I read, let's jump back to the other slide. When I read this code to you, I was essentially conveying it to you in pseudocode. I was doing it after the fact. The code was already written, but if you are new to a language or you're still learning the syntax or you want to convey information to another person, oftentimes you can write it in pseudocode, which is just plain English that really explains the program, the branches, the loops, etc., etc. Code commenting is key. Always comment your code. Always act like your code is going to be handed off to someone else, and that person has to be able to read it and understand it. Well, we talked about variables before. Variable A. Name your variables. Depending on the rules of the language you use, name your variables so that They are understandable and human readable. I don't know what this probably shouldn't. The industry standard, 10 bugs for every 1,000 lines of code. That's a bunch of junk. The more code you have, it becomes exponentially more complex. The complexity of your code increases exponentially as you add more code. So saying it's 10 bugs for every 1,000 lines of code isn't even a good rule of thumb. It's just a bunch of junk, and I really don't know why they put it in there. Windows 10 contains over 50 million lines of code. Yes. And when I was at Microsoft, working on Windows 7, came right after Windows Vista. Yeah, there really is that many lines of code. I don't really know where they got their information that there's fewer bugs than average, because the whole point of bugs is you don't really know, right? You can test, you can set some criteria on what bugs you fixed or not, but Microsoft is definitely not going to release that information, so the book is making a statement that isn't necessarily true. Dennis Ritchie developed C at Bell Labs. It really is one of the most powerful languages that you can write in, and unless you're writing firmware, you're probably not going to write in it. Unix was written in assembly, moved to C. Yep, C++. Definitely much more widely used. Essentially, it enhances C, adds true object orientation, adds standard libraries. C++ is something you're definitely going to encounter in your career. A compiler takes the code you write and converts it into machine code. That is different from scripting, where your code is interpreted on the fly, sometimes moved to what's called an IL, or an intermediate language. Here's a bunch of compilers. So you have Intel's compilers, VC++ by Microsoft, and GCC. Those are the most common compilers you're going to use. Again, I don't know why the book is trying to show you about C, talk to you about C right now. If you haven't programmed or you're new to this, don't start off with this. Go start with Python. Go start with a scripting language, VBScript, something that gives you the core concepts of programming and not the junk syntax that C is going to be extremely complex for you to learn starting off. So, just a heads up, you should learn it, but don't sit there and focus on C right now. If you're new to it, go focus on something else. All right, the Hello World program in C. How does this work? Let me just walk you through the code again. I'll talk about it in pseudocode. Hashtag, since that's # includes a file. Here we're including the standard input-output library, stdio.h. That allows you to write to the console or read from the console in C. So includes are different modules or functionality that you can include in code. The main function is the entry point in your code that when your code is interpreted, that will be the piece of code that it goes to in the machine language or binary that the computer will execute first. It jumps to the first line, printf. Printf prints to the screen the string literal, in quotes, hello world, escape, and which shows 2 new lines. And that's all the application is. It prints hello world and 2 blank lines to the screen. / asterisk, and then asterisk / multi-line comments. 2 / are 1-line comments in C. # include statements, again, local libraries or modules that you can include in the program. Parentheses means you are dealing with functions. A parenthesis, yes, on the face of it means you're dealing with a function. Parentheses encapsulate in function definitions parameters and encapsulate arguments when you're calling a function. That's what the parentheses indicate. Parentheses also encapsulate conditional statements that for ifs and else ifs, etc. And the main function, again, it's required by every C program, not by every library, and I don't think the book goes into that, but that is the entry point to your application. Braces, squiggly lines, that's a block of code. Functions can call other functions. Functions can be recursive. Parameters, i.e. arguments. I love people use this interchangeably. Parameters are the variables that you use when you define your function. Arguments are the data you pass into the parameters. The book here is interchanging them. Some places do interchange them, but the true definition are parameters is the definition and arguments is the data. Declaring variables. What is a variable? A variable is a representation of a place in memory. That's all a variable is. It's a human readable representation of a place in memory. It could be a number, it could be a string, it could be a list, it could be an object. It could be a lot of stuff, but you use it as a reference. You can't add, for instance, a string hello world to an integer 1. How do you add 1 to a piece of text? You can't do it. So oftentimes you have to convert values. Those are called converters or transforms, and that's how you convert variables of different types. Variables of different types also take up more or less memory space. So for instance, a bit takes up 1 bit of memory, whereas an integer, depending on the size of integer, could take 2 to the 64th bits, or 2 to the 32nd number of bits. It really depends on the size of the variable. Here are some variables: an integer or an int, a positive or negative number, as we talked about before. A float is a number that may or may not have a decimal point. A double has a decimal point. A character is a single character value, and depending on what's called your character set, this could be standard US ASCII, this could be UTF-8, UTF-16, so various Unicode formats. A string, what's a string? Everything is a string. The text, this variable type holds the value of multiple characters or words, that's a string. A const, the book calls it a variable type, and again, this goes back to the many problems I have with this book. Constant isn't necessarily a type. A constant means a value doesn't change. So for instance, you can have a constant integer. You still have to define a variable as an integer. But what that means is the value you initially set to the variable, you can't change it. It is constant, hence the name. Conversion specifiers in C. This is actually called string interpolation, but okay. So if you have a string, and I don't know where in here. So I'm going to jump through this code real quick. Here's an example. Counter is equal to percentage sign $d. What you're saying is we have a number of arbitrary parameters in the printf function. Percentage sign $d says counter is going to be a decimal or an integer. Throw that in there. So a decimal number, for instance. So automatically convert it. So you can use these conversion specifiers when you are using string formatting functions such as printf. You know, it feels to me that as I go through this chapter, it really bounces around places. And like I said, I encourage you to go actually back out and learn a language if you haven't experienced it. This is definitely not a tutorial to programming. This is a very high-level overview and really not, I don't think, ordered properly, but it is what it is. So yes, there's a lot of various topics this chapter, so bear with me. And the operators compare values within what are called expressions. So 2 plus 2. The expression is 2 plus 2. The operator is plus. That is addition. You can have subtraction, multiplication, division, modulo arithmetic, bitwise and bitwise or. These are all operators. Some of them you haven't heard of. That's okay. If, again, you dig into programming, you will. There's mathematical operators, and there's logical operators, and there's bitwise logical operators. Various operators, as I talked about. You have plus or minus. You have increment and decrement operators, plus plus and minus minus. All of these can be used in various expressions. Now, these are comparison operators. So you're comparing two things. So is A equal to B? That's two equal sign. Is A not equal to B? Bang equal sign. Is A greater than B? Greater than Pac-Man, less than Pac-Man, etc., etc. The result of these statements is true or false, right? You're trying to determine truthiness, as they say. Branching and looping and testing. Again, we talked about this before, but I'm in a main function. I have a function prompt. I jump to prompt. I run the code. I run the code within prompt. When that code is finished, I jump back up. I run display. I go to the function display. I run the code contents in the code block for display. And then I jump back to calculate, and so on and so forth. A while loop iterates. So a while loop, you can have a counter. And then you can say, okay, while this counter is less than some limit or greater than or some limit, while this still evaluates to true, do whatever is in this code block until this statement evaluates to false. So what does this code do? It prints the value of counter to the screen. It increments the counter. And as soon as counter is 11, it stops executing this code. And here is an example of this code running in a compiled version of the application. A do while loop or a do loop is the same thing, but the evaluation occurs at the end of each iteration. And then a for loop helps. A for loop makes it easier to define the loop, because what you do is you declare the variable, you determine the condition, and then you set the expression to be evaluated at the end of the iteration. So here it says, I'm going to use a variable counter. It starts with 1. Evaluate while counter is less than or equal to 10, and at the end of each run of the code block, increment the counter by 1. So a for loop essentially allows you to combine all this goodness into one line. Here's an example of the for loop. Okay, so HTML. What's HTML? HTML is a markup language, and it's really just used for web pages. Similar to the extensible markup language, XML, which is used to format data sets. In the case of security professionals, you're going to use this not only to look for weaknesses in web applications, to evaluate for information and potentially look for scripts embedded in web pages that could lead you to an access point into an organization. But you're also going to use this to spoof web pages to harvest credentials through phishing attacks, etc., etc. Yes, you can write HTML in text. You can do it in Notepad, Notepad++, Vim, Emacs, anything you want. This HTML isn't a true programming language. It's a markup language. You are defining how text and data should look in a browser. And this is done through the use of tags. Each tag has an open and close matching tag in most cases. And a tag is defined through the greater than and less than symbols in the name of the tag. So for instance, if you want to bold a word like sparkling water, you would put open, I guess that would be less than, B greater than, so that's a tag for bold, sparkling water, and then less than / B greater than, and that would be closing the bold tag, and that's how you would show that text in bold using HTML. Here are various opening and closing tags that do various things in HTML. So the H series of tags represent headers. P, paragraph. B, bold. I, italic. Here's an example of a web page written in HTML. First line is a comment, less than sign, bang, 2 dashes, whatever your comment is, 2 dashes, greater than sign. HTML, that's the start of your page. Remember, it has a closing tag at the end, whack HTML. The head is header, so defines what are the attributes of the page, what are these search terms, what's the title of the page. The body is what's displayed to the user in the browser. So for instance, here we have a header. H2 is the second level header security tester website. Then we have a paragraph. Bold text. There are many good websites to visit for security testers. For vulnerabilities, click. And A tags are hyperlinks. And you go to that link, and then whatever's between the hyperlink is what you can click to go to that link. And this would be your CVE at MITRE. And then you have another paragraph, and then you close the body of the page, and then you close the page. Here's an example of what that looks like. As we said, here's the header, here's the bold text, and if you click here, here is the link. All right, so we talked about a language C, and C gets compiled into an executable file. We talked about HTML, which is simply a markup language, it's not a scripting language, not interpreted language. It just marks up text. Finally, we have Perl, and Perl is a scripting language, so it gets interpreted on the fly. It's not compiled into an exe file. Practical extraction and report language. That's what Perl stands for. Again, it's just scripts. It's very powerful. Perl and Python are two very popular languages. I would say start with Python. It's a bit easier to learn. It was written by Larry Wall in '87. It's by default installed in Unix flavored operating system. Syntax is similar to C. And, evil hackers use Perl. Yeah, lots of people use Perl. Banker use Perl. People at home trying to organize their photo library use Perl. It's just a well-known, well-written scripting language. Perl-H gives you a list of parameters, and Perl-Doc is a description of the Perl print command. If you want to run Perl, here's some various commands you can run using the Perl help command. And here is the Perl-Doc command. All right, some basics of Perl. Remember, syntax is similar to C, so printf. Prints to the screen. Printf, again, it means print format. So print formatted, where you have a string literal followed by various parameters that can be dropped into the string. You have formatted output characters. Again, C is character, S is string, etc. D is decimal, just like C. Well, look, it's the bacon, lettuce, tomato again. Okay, so function names are defined using the sub keyword variable. Start with a $sign. Comment lines start with a £sign or hashtag for the Twitter generation. And the ampersand symbol indicates a function. Here's an example. How does this work? We're defining a variable. First name of Jimmy. Last name Hendrix is another variable. We're defining a function named best guitarist. And now we are declaring the function named best guitarist and putting in the code. And what are we doing here? We're printing a string with 3 parameters being shown, where the first parameter, we're passing in an argument first name, we're passing in an argument last name, we're passing an argument was the best. So this would read out Jimi Hendrix is the best. That is also your opinion. There's a lot of opinions in this book, not a lot of facts. For loops. Again, similar construct to C. While loops, similar construct to C. And like I said, once you start learning these programming languages, a lot of it's going to look the same. Just little bits of syntax changes here and there. Conditional testing. Also cool in Perl is the concept of else if combined into one, so it's multi-condition. Other languages use else if, all one word, elif, but it's just another concept. Also the unless concept as well in Perl. So a little bit more extensibility in terms of conditionals. Here are various operators in Perl. These should be familiar because they're pretty much very close to C. All right, finally, object-oriented programming, or OOP, essentially takes the concept of objects. You can have things, and things have attributes, and things do stuff. So you can have properties, and methods, and constructors, and destructors. Objects can have garbage collectors. Everything that you can imagine that a thing can do, a can, a desk, a chair, a mouse, these can all be represented in programming languages through object-oriented programming. So, again, structures of whole data and functions, verbs and adjectives, the double colon symbol is used by certain languages. Again, let me caveat this. It could be the dot syntax. It could be the arrow syntax, which is dash greater than sign. There are various ways to define classes. So here, what is it saying? We have an employee. We want to call the method getEmployee, or member function, as they say. So here, we're defining a class employee. Employee has the attributes, a first name and a last name, both up to strings up to length of 25 characters. Place of birth, a string up to length 30 characters, so on and so forth. And this employee, you can say get employee info, and it will return info. So it's the programming representation of a real employee. Here's some various Win32 API functions, and I really don't know why they put this in here. The Windows API, number one, most of the time it has nothing to do with classes. It has nothing to do with object-oriented programming at all. The Windows API is a super powerful and very complex application programming interface for manipulating the Windows operating system. So whatever this book is saying in this chapter to review on WinAPI, please review it. It's very important if you're working in Windows. But I have no clue what this has to do with object-oriented programming. All right, Ruby, no one's using it anymore. Don't bother. Yes, Metasploit is Ruby-based, but the number of programmers who are actually writing in Ruby now is tanking. Look at Python. And remember the videos, we've done this in 2020, so 5 years from now might be something different, but nobody uses Ruby anymore. Here's an overview of Ruby. Don't bother. Don't bother. Let's talk about the end of the chapter. Pseudocodes and algorithms. Remember, algorithms are the steps to perform a task. Pseudocode is conveying programming in English language. Always good habits to comment your code. Always good habits to write in pseudocode. Make sure your program's documented. C's pretty popular if it's 1980. Bacon, lettuce, tomato, branching, looping, and testing. C compilers, there's lots of them. Remember Intel, Microsoft Visual C++, GCC, those are your most common. HTML isn't a real programming language. If someone tells you they can program and the only language they know is HTML, they're not a programmer. Perl and C are programming languages, yes, but remember C is compiled and Perl is interpreted. Object-oriented programming, OOP, concept of classes, WinAPI, completely out of place in this chapter, but it is the application programming interface to the Windows operating system. And Ruby, no one uses it anymore. Have a great week.